All right, guys, welcome back to another lesson for Algebra 1. This is going to be lesson 113, and it's going to be interpreting the discriminant. So it sounds hard, but I guarantee you it's not very hard. You do, though, have to understand lesson 110, the quadratic formula, so that you understand the discriminant. But if you understood lesson 110, so you won't have any problems with this one. So let's get into the lesson, because after we're done, it would be just 7 more classes to go. Praise the Lord, I'm almost done with this. So let's get into it. Okay, so if you recall lesson 110, we know that standard form of a quadratic formula is 4x, or the quadratic function, not quadratic formula, is f of x, not 4x. Function of x equals a of x squared plus bx plus c. And so when we can't really factor out to find the zeros or the solutions, meaning the x-intercepts, the roots, we use the quadratic formula. And the quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. You should already know how to like that and what it means and everything like that. However, today we're talking about the discriminant, and it has to do with something here. The discriminant more directly, it deals with this. This is the discriminant. The discriminant then is b squared minus 4ac. Right? This is the discriminant. And so what does it tell us? The reason that the discriminant is important is because it can tell us several things, okay? And so you don't have to go and try to do everything else in the problem if you already know that you're looking for one solution, two solutions, or no solutions. Real solutions, okay? Very important, okay? They're called non-real solutions when there's no solution for a quadratic function. So what this means is that if you get the discriminant, and the discriminant is less than 0, meaning any negative number, if the discriminant b squared minus 4ac is less than 0, then this is what happens. It has no real solution. It doesn't cross the x-axis. Does not cross x-axis. Whoops. So it doesn't cross the x-axis. What about here? If b squared minus 4ac equals to 0, then it has one real solution. So it has one x-intercept. Okay? What about this one? B squared minus 4ac is greater than 1. Is it greater than 1 or greater than 0? Greater than 0. Sorry. So it doesn't matter. It has to be positive. It doesn't matter if it's positive 0.2. Then it means it has two real solutions. This real I don't like. Two real solutions, meaning two x-intercepts. I'm just going to put, int, because I guess you guys should know by now. So if the discriminant is less than 0, meaning any negative number, it doesn't matter what type of negative number, it has no real solution, it does not cross the x-axis. If the discriminant is equal to 0, it has one real solution, and it has one x-intercept. If the discriminant is greater than 0, any positive number whatsoever, you would have two real solutions, two x-intercepts. And that is how you do the discriminant. And so let's actually move on into the example 1, which is the only one we're going to do. Wait a second. Before we actually go to that, it's bonus time. So you know, the first 5 people that comment down below what your favorite food is. Just that. You just have to put your favorite food. Comment down below. 5 first comments on YouTube will get 3 points. If you are the 6th, 7th, or 8th person to see this, and the YouTube points are already gone, You can then go to Google Classroom in the link where I post the video, and you can put what your favorite song is right now. I know that song is a very subjective thing. It changes as you grow older and you listen to new music and new music comes out. But right now, what's your favorite song? Yes, now we can actually move into example 1. Okay, so the first example is divided into 3 sections, pretty easy. X squared minus 3x plus 9, 2x squared minus 3x minus 4, x squared plus 8x plus 16. And always remember the discriminant. The discriminant is b squared minus 4ac. Pretty easy. So I'm going to just leave it there because it applies to the 3 examples. And let's actually look how the examples say. So the examples say the following. We have the b being negative 3, so it's going to be negative 3 squared minus 4 times a. A is 1 because I have no coefficient for my cubic term, quadratic term, not cubic, my bad. And then 9 is going to be my c, right? So negative 3 squared is going to be 9 minus 1 times 9 is 9 times 4 is going to be 36. 9 minus 36 is going to give me negative 27. Okay, negative 27. Because it's negative, I already know negative 27 is less than 0. And because it's less than 0, we're going to say it has no real solution. It doesn't cross the x-axis. So it has to say no real solution. It doesn't have any x-intercept. Now, what about the second one? The second one then, we're going to use the same thing, b squared. So b squared is, again, negative 3 squared minus 4 times 2 this time times negative 4. Be careful with the negative and negative. Negative and negative is positive, so it's going to be positive. 4 times 4 is 16 plus 2 times 2. 4 times 4 is 16 times 2 is 32. Negative 9 squared is 9. 9 plus 32 is going to be 41. It has 2 real solutions. Meaning it has solutions, meaning it has the 2x intercepts. I'm just going to check how the book says it. There are 2 real solutions, so the graph has 2x intercepts. Exactly what I said. It has 2 real solutions, 2x intercepts. All right. And now the last one, b squared is going to be 8 squared minus 4 times 1, because a is 1, and c is 16. 16 times 4 is 64. 8 squared is 64. 64 minus 64 is 0. It has 1 real solution. One x intercept. And that's it. That's it for this lesson. All you have to know is the discriminant, b squared minus 4ac. If you ever forget what it is, it's going to be what's underneath the radical in the quadratic formula, negative b plus minus square root of b squared minus 4ac over 2a. And that's pretty much it. Yay, lesson 113, done. 7 more lessons to go. I'll see you guys in the next one.